Hi there, this is exercise 7a for further mathematicians. We're looking at a completely new area of mathematics which we're going to explore in the last few lessons before the end of term. And I think Miss Frovine's going to look at another one as well called complex numbers, which you've already seen a bit of. But this is statistics, and this is looking at probabilities. And this is an attempt to, if you like, do proper maths, do proper algebra with statistics, and that's what we're going to look at. Now, first of all, I'm not sure what you recall about probability, but sometimes we have what are called PDFs, and a PDF is a probability density function, and it's an attempt to write a function which describes the probability as x values change. So here you can see we've got x values presumably going from 0 up to maybe 1 eventually, but in between you've got 0.2 and 0.3, and for each of these values you assign a value of the PDF, of the function. And so when, let's say that's 0.15, at 0.15 we have a value over here, and at 0.1 whatever we have another value, and it's basically just we give a curve to the probability. And obviously the basic idea is the higher the curve, the more likely it is to happen with that value of x. And so we're looking then for a numerical x value which, as it changes, the probability of that occurring changes. So let's have a look at a few bits and bobs of this. So these are called probability distributions or probability density functions. One thing you'll notice is on this picture how it really isn't just a case of the height of the function. The height of the function gives an indication of what the probability might be at these different values. But I say that guardedly, because really what we're looking at is the area between a couple of values will really tell us the probability of it occurring between these two values. So for instance, you can have an fx value which is greater than 1. So it can't be a probability. It's just a measure, one way of understanding probability sort of visually. So just be aware of that. F of x is not the probability, but it kind of represents something similar to it. So one thing we can definitely say is, since all probabilities are positive, f of x has got to be bigger than 0. But note, as I've already said, it can be bigger than 1, so it can go up forever and ever and ever. But definitely, this slightly weird measure of probability, something-ish, can't be negative. So f of x is always greater than or equal to 0, I suppose. Can it be? Yeah, there would be places it could be. Well, I don't know really. I've written f of x is greater than 0, so I'm going to stick with it. But you never get this problem. So basically, just in your mind, f of x is always positive. Now, the second one is that probabilities, we do know, add up to 1. And as I've kind of hinted here, the area is what is important. And since the area is important, if I was to have the whole of the function, then all of that area must equal 1. And of course we know that if we integrate, this is the algebraic part, if we integrate between two values, where a is the start of where things start happening for this function and b is the end point, then the integral from a to b of f of x must sum to 1, must equal 1. That's an important second rule. And we have a third rule which is kind of linked to that, and it says even though a and b were the start and the end point, so for instance if we had a function which looked something like this, I don't know exactly what it looks like, and sometimes these things just stop dead like there, there's a value for it, so there's between 0 and I don't know, 10. Now it may well be that we want the probability between 2 and 3, and we could find the area between 2 and 3 for this function, for this PDF, for this probability density function. And so they were just saying the probability between these two numbers is the integral between these two numbers. Basically it says, if we want the probability, we integrate. Now a couple of things we might be asked to find the mean, or sometimes called the expectation, or E of x, of this PDF. For a PDF, if it is, I mean, you can see here, this is broadly symmetrical, but not quite. Sometimes it's exactly symmetrical. You know, they draw it and it goes up, and then it goes down. And, you know, if you set it right, that's 0, that's 3, and that's 6. You're thinking to yourself, well, okay, then, that's exactly symmetrical. It basically tells us that E of x, the mean, in this case, is exactly 3. And you can just see it by symmetry. So look out for symmetrical PDFs, because it tells you that the expectation, the mean, the E of x, is right bang in the middle of it. Let's do this question here after 6 minutes of just talking about it. So we've got kx squared. So the first thing I notice about this, obviously kx squared is, well, I know what x squared looks like, but I don't know the value of, so it could be anything, I suppose. But I don't really care about that. It will be broadly, you know, this is the shape for an x squared graph. You know, we all know that. But ours only exists, this is what this says, it says the function equals kx squared between 1 and 4. So there's 1, and there's 4, and the function exists between those 2 points. Everywhere else it's equal to 0. That's why I wasn't quite convinced by that f of x thing. This f of x is equal to 0 outside of the range of, you know, the two numbers, I suppose. I suppose that might be where it's getting from. And if I was to work out this area, it has to equal 1. So that's the very first thing I'm going to do, and that's what part 1 wants me to do. So if I integrate kx squared dx between 1 and 4, my answer has to equal 1, because the area is always equal to 1. And that's my function. So if I integrate that, I add a power and divide by the power between 1 and 4. And I know that's equal to 1. Now if I put 4 in, I get 64 over 3k. And then I take away what I get when I put 1 in, which is 1k over 3. So you can see straight away that 64 minus 1 is 63, divided by 3 is 21. So that says 21k equals 1, or k equals 1 over 21. That's what I think it is anyway. Sketch the probability distribution. Actually, I've already done that. This is part B now, and this is part A. So this is what they mean when they say sketch the probability distribution. Put a couple of arrows on it to make it look posh, but essentially it's that. Notice how if it was me in the exam, I wouldn't draw this dotted line. I would just draw the fact that it goes on 0, goes up to this x squared curve. Notice really it's kx squared, but we don't really care about that. And it goes across. And we now know that k is 1 over 21. Explain the relationship between x and x. I would write something like x are the values that the variable x, capital X, can take. That's how you need to write that answer. This was from an old exam question, and they've got into a habit of always asking the same thing because people never got them right. Find the probability that x is less than or equal to 2. Well, to go less than 2, you'll notice you can't go lower than 1. So really, the probability that x is less than or equal to 2, we're going to integrate from 1 up to 2 of my function. And my function now I can write a bit better than before. It's 1 over 21 x squared dx, because I know that k is 1 over 21. Again, integrate it, add a power, divide by the power. So that's 1 over 21 of x cubed over 3. Between 1 and 2. Now if I put 2 in, I get 8. So that's 8, and now 3 times by the 21 is 63. minus, I've put 1 in, it's still 1. 21 threes are still 63. So I think my answer is 7 over 63. And I've got the last one. It wants me to do it between 3 and 4. So the probability that x is between 3 and 4. You can notice we're doing really the same integration lots of times. So between 3 and 4, 1 over 21x squared dx, this is equal to, well, it's still x cubed over 63, because that's what that ended up being, 63 on the bottom. But now between 3 and 4. I've put 4 in, I get 64 over 63. If I put 3 in, I get 27 over 63. What's that? 37 over 63? I think it is. Don't think that simplifies. Let's see if they're the right answers. Yes. 1/9 I've got for part 4. So is that right? Yeah, of course it is. That's 1/9. I didn't simplify. But other than that, it's right. And the last bit is 37 over 63. And notice x is the value that the variable x can take. So all correct. Let's do the next question. Alright, now first of all we've got a sign here, so we've got to do the same thing. To find the value of this, we're going to integrate between 0 and pi. Now you know why we did all this stuff on integration. K sine x dx. This was actually an exam question again from the OCR. And if you integrate sine, I think you get minus cos. So I reckon this is minus k cos of x between 0 and pi. So let's put pi in. That will give me minus k. Cos of pi is minus 1. Minus, I put 0 and I get 1. So I get that minus a minus k times by 1. So I think that's k plus k, which is 2k. And we know this thing has to equal 1, so this equals 1, k equals a half. Happy with that. Sketch the probability distribution. So again, for part 2, it's only between 0 and pi this thing exists. Now, pi is 180 degrees, and I know basically it goes up, and it comes down, and then it stops dead. That's pi. There's 0. And either side of it, a lot of people like you to draw that, those lines solidly, so it's obviously 0 beyond those points. This is f of x, and this is x. Write down the value of e of x. Well, e of x, notice this symmetry here. We talked about this before. There's symmetry. I reckon pi of 2. Or pi over 2. So I'm going to write this equals pi over 2. And find the value of m such that the probability that x is bigger than this number is 0.25. Okay then. So we've got a value of m, 0.25. This is symmetrical, so this is a half. M must be about here somewhere. That's m. And I want this to be 0.25. So by definition, I think the other side of it, all this lot, is 0.75. That's what I'm going to do. I'm going to say the integral from 0 to m of k sine x dx equals 3/4, 0.75. So it's slightly different. K I already know is a half. When I integrate it, I get a minus, so it's minus a k, a half cos x between 0 and m equals 3/4. Chuck m in, it's minus a half cos m minus, now put 0 in, it still gives me the same. It still gives me effectively minus k times by 1, so it's plus k, which is a half, of course. So I'm going to pause this and write this down. So I've written out all my solution. Hopefully you can see what I've done. I've worked this out. I've moved the half over to get a quarter. I've divided by the minus half, and I've inverse cosed. And I ended up with an answer of 2/3 of pi, which I just checked, and it does work. So this is what you need to do. The only hard ones really are the ones which give hard integrations. Most of them won't be. Exercise 7a, I bet most of them are fairly straightforward. If you get any hard ones, let me know.